Good night, everybody. We're looking for a solution in the set of integers from 1 to 78. Now, that is the set of remainders that you get when you divide any integer by 79. Now, I left 0 out on purpose. 0 factorial by convention is 1. This is also consistent with the definition of factorial, but for now we'll just state that 0 factorial is 1 by convention. Makes a lot of the formulas work in statistics. The combination and permutation formulas would break if this convention wasn't, if this was equal to 0, for example. Now let's take a look at why I left it out. It's an easy check. If we take x to be equal to 0, this would just become 1 is congruent to 11, right? Which is certainly false, all right? 11 minus 1 is not a multiple of 79, so we can write down 1 is not congruent to 11. So that's an easy check. But let's see if we can find some others that are non-trivial approaches. And of course, those of you who've taken number theory know that Wilson's theorem is going to help us out immensely right here. Now, this is Wilson's theorem. 79 is a prime number. 79 is a prime number. So this is just a special case of Wilson's theorem. And so the benefit of writing it like this is you can treat the congruent symbol, the triple horizontal bar, as an equality. So in order if this were just a regular equality and you raise it to the 4th power, this is what would happen, and nothing's different. Okay, when it comes to congruence. Okay, there's some subtleties, but basically it's much like equality. Okay, so it's reasonable to check out what would happen with 78. And also to observe this string of congruences. Each of these is a multiple of 79. From here to here is 79, from here to here is 79, and so on, the difference, right? And so we get out to 396, and 78 would not be a solution, since you can just tell when you substitute in, you get 401, which would not be a number in this list, right? So for that reason, 78 is not a solution, all right? No way, because the next one would be what? 475. I can put 475 here, just right there. Okay, that would be the next one. And it goes on forever, but anyway, that helps a little bit to see that large number 475. Now, so 78, not a solution. Now let's move along. Now the nice thing about Wilson's theorem, folks, is you can kind of unwrap it. Right here, you can see what I've done. I replaced 78 factorial with what it's equal to right here. It's equal to 78 times 77. But 78, let me write, whoops, sorry, I don't know where I'm at here. 78 is congruent to -1. Because the difference between 78 and -1 is 79, right? Okay, so that's why you can physically replace 78 with -1, okay? And also, folks, this is a divisibility statement. It would say that 79 divides the negative number, or 77, in fact, that 79 divides some negative number, probably. Yeah, and so that means it's going to divide the corresponding positive number. A better way of putting it is, like 2 divides -8 would imply 2 divides 8, right? It's the same thing right here. This is just congruence, which is divisibility dressed up with different notation. Okay, so what we know is that 77 factorial is congruent to 1. Also, right? Okay, so now let's take a look at what happens. Okay, so we know that 77 factorial is congruent to 1. So that means we know that 77 factorial quantity to the 4th. Okay. Now, let's check. And this is, I should be writing this sort of at a, like, question mark, okay? I'm not asserting, okay? 5 times 77, you would have 5 times 77 right here. Plus 11. Okay. And what's that? That's 385 plus 11 equals 496, right? Or 396, 396, excuse me. Okay, so 77 does work because we have 396 in this list, right? So 77 is a solution. Okay, that implies 77 is a solution. Now, y'all, I'm not going to try to go through and show you there's no more solutions, but I'm almost certain there isn't. It's just because, well, I don't, just intuition, I guess. I don't think Wilson's theorem would ever combine in a way where, or anything else, would combine up here to where you'd get a number in this list. Okay, now again, you're kind of going, well, how do you know how far out on this? You're right. But I'm not going to argue the case too strongly. I think 77 is the only solution, but I certainly haven't proven it to you. Okay, so I'm just saying 77 is a solution for now, and that'll be all on that matter, because it's a little slippery, in my opinion. You could check, you'd have to go through what happens with 76 factorial. Okay, but you can see that the numbers are getting smaller, but you could maybe work your way back to some of the smaller numbers. I'm not sure, okay? I'm really not positive on this at all. But remember, I'm careful about the way I word the instructions. It says find an x, okay? I didn't say find all x. So the one that we found was x equals 77 is a solution. And again, my intuition, for what it's worth, says there are no more, but since you have so many possibilities in this list, literally an infinite number of values, I think, this is increasing, but I don't know really. I just don't know. Let me know if any of you guys know whether or not. I have a feeling 77 is the only one, but I know that's far from rigorous. It's nothing like rigorous mathematics here, just to posit your opinion. But we did find a solution, namely 77. Okay, you get everything? Yep, that does it. Okay, thank you for viewing.